About gaps to autonomy, I am happy to invite our moderator, Jason Stein, Vice President, Publisher of Automotive News. If you can all come and sit with us. Joining Jason will be Glen de Vos, CTO of APTIV, Ophir Zamir, Director of Solution Architecture at NVIDIA, Micha Risling, Senior Vice President of Marketing and Business, Head of Automotive Business at Valens, and we're still looking for Erez Dagan from Mobileye. Come and join us, please.
Thank you. Sure. Well, good morning. It's a pleasure to be here with you. First time in Israel for me, and I think a pretty, as you heard earlier, a pretty active, engaging conversation. We have three very interesting panelists here, but I'll start off as we wait for our Mobileye speaker. I think Mobileye was already making news this week, which I know would be interesting to the three of you, in the sense that Mobileye had signed a contract to supply 8 million cars at a European automaker with self-driving technologies. So, Glenn, I'll just start with you. This world continues to be a rapidly changing world, and one where there is now real advancements and real vehicles about to be put into place. Give us your perspective on that at APTIV.
Yeah, I think what that highlights is the, and I ran into Jim Biskowski here from Ford earlier. He used to use the term democratization of ADAS and those feature sets. And really what you're seeing is that proliferate down into the value segments and really across the entire vehicle lineup. So these types of announcements really reflect the broad adoption of ADAS technologies, and that reflects a strong commercial pull. The end consumer values these. OEMs can make significant profits by selling those feature sets, and so we see that pulling all the way from level 1 to 2 to 3 and then up.
Micha, your perspective, just given the some of the latest hard news that's come out?
So every announcement like that is quite important because it basically shows the way that the industry is moving on. There are still lots of challenges that needs to be addressed. I think the main one is with respect to lowering the cost of the solution. This was also included in the announcement. The expectation that the cost will be at a level that might take some time before the overall industry will adopt that. And I think we and many other startups that are working in this scene are really trying to see if there is a way to bring the technology to a level that it will be able to lower the overall system cost. I think it's another step, quite important, but I don't think we are there yet. And there are challenges, but working very hard to fix those.
So, Ophir, let's talk about those challenges. And I know that your company's been extremely active in this space and developing technologies at a rapid pace. What are you seeing as some of the significant challenges and/or gaps, which will lead into that part of this conversation?
So, obviously, connected cities, connected cars, autonomous vehicles are really an industry effort, not a single company. And we try to embrace as much partners that we can in academic and researchers and many startups and large tier ones and OEMs to really form an ecosystem that can share best practices, share data in an efficient way. It's challenging because, as we know, in artificial intelligence, data is very important, and people try to capture their IP and their data. But I think it's important to define probably government initiatives for sharing information in order to accelerate the entire market.
So we'll stay on government initiatives with you for just 1 second. How realistic is that? Because there are some situations that work out better than others, and some communities more responsive than others to those. At what point do we have to get to where adoption will be possible at that local level?
So I agree. It depends on different regulation, different countries. We see more advancements in US, for instance, than Europe. But overall, I think that the industry now is mainly focused on developing the platforms, the tools, And when times comes, evolutionary cities will adopt the technology. It's also very important to educate and to give confidence to governments, to citizens on the maturity, and not less important, the benefits of connected cars to the citizens and to improve our lives.
Okay, Micha, you had talked about challenges a minute ago. Let's talk about a couple of other gaps. What do you see in terms of the challenges in front of the autonomous space?
Yeah, so one of the main challenges we see is with respect to the future architecture of the cars, and this, of course, will also drive the cost. And there are many aspects. Many of them are being dealt by so many companies like NVIDIA and Mobileye, and all the companies that you can look around and see so many of them with respect to sensors and LiDARs and all those stuff. We are specializing on one topic that doesn't necessarily, at least from our perspective, is being addressed well, and this is in-vehicle connectivity. Because eventually, if you look at what the cars, the architectures will have to support, it's a huge amount of data. Huge amount of data moving throughout the car from the sensors, displays, ECUs, and somehow you need to connect that together. And if you don't connect that in the right way, meaningly very low latency, high speed, cost, weight saving, you ended up with a system that will not necessarily be able to meet the requirements. And this is exactly what we specialize at. Together with some partners, we have a strong partnership with APTIV. And what we did, we came up with a solution that allows you to drive huge chunks of data over very low cost channels, which hopefully will allow the tier ones and the OEMs to get to the architectures that they would like to have.
Glen, where are the architectures now and how far do they have to go, just to Micha's point?
Yeah, if you think about automated driving and really in the markets, there's really two markets that we talk about. The first is the commercial market where the initial deployments will take place. Those are with ride hailing or mobility on demand, so demand network operators like the Lyfts and the Ubers. That's relatively near term because those architectures, by and large, are what we refer to as bolt-on architectures, where you basically add on top of the existing automotive architecture. It's much more costly, it's much more inefficient, but the economics of that market can support it. When we think about the OEM or the consumer market, that's where you can't use a bolt-on approach. It's just too costly, it's too inefficient, it's too cumbersome. That's where you need this next generation, what we call smart vehicle architecture, that allows you to fully integrate the technology into the car, move that data around efficiently, as Micha was just describing, that Valens helps do, and then basically you really have the vehicle as a software-defined platform at that point. That's a very different architecture than there is today. We're starting to see the move towards that. The Audi Z-Fast program, the A8 that was announced, was a big first step. BMW's lineup that they've announced is the next big step. We're seeing that broadly applied, so that'll take place really over from about 2021 through the end of the 20s. That you'll see that transition occur, and that's when level 4 and those types of systems will be cost effective.
So for what, just to stay with you for a second, so for a while we're going to be operating in a little bit of a dual world. What does that mean for a supplier having to have one foot in the present and one foot in 2030, I suppose?
Well, for us, we think it's really important to participate in both. And the reason we say that is we know the technologies that we can develop on the commercial market, we can apply to the broader OEM market. So we see, for instance, our engagements with Lyft and others as very important for advancing our automated driving technologies. We then basically move those over into the OEM space. So it really accelerates our OEM development. So for us, we think it's really important to have a foot in both.
So I want to go up to 2030 with you as well for a second and just talk about what that architecture then looks like.
So at that point, by 2030, if you think about it, it's 12 years away.
It's not that far away.
It's really not in automotive timeframe. But you've really completed the centralization phase where you've brought in compute within the domains. So the safety, the body, the cockpit, the powertrain, those have been centralized. You have a much richer set of sensors around the vehicle. Our automated vehicles today take in about 50 terabytes an hour of raw data. You'll probably be at 2 or 3 times that with the next generation of cameras, LiDAR and radar. And so you'll have much, much better and faster networks. I mean, we're talking up to a 50 gigabit per second type of transmission in the vehicle, feeding those central compute. And then those cars will be fully connected. So architecture isn't just on the vehicle anymore. You have to think about it as part of the cloud and the client being the vehicle. So it'll really reshape how we think about vehicle architecture.
Okay, now Micha, when you look at, that's the platform, but then what's the infrastructure around it? And gaps in autonomy, we talk about smart cities now. Where are we from your vantage point in terms of having smart communities or communities that can handle the types of vehicles that Glen talked about?
Yeah, so this is a topic that Valens as a company is less involved in. What we are dealing mainly is traffic that goes in within the car. But I'll let the gentleman to feedback on that one. But from our perspective, what is important is that eventually you need to have a lot of throughput outside of the car. Okay, there are discussions today about 5G, taking it all the way up to speeds of 10 gigabit per second that gets into the car in order to allow the infrastructure that you were referring to. And then the bigger challenge is again, okay, you have the infrastructure outside of the car, now what are you doing inside the car with this huge chunk of data, and how are you going to distribute that? And what most people are not familiar with is the challenges that a car is not just another platform, okay? People now believe, and I do agree with that the car will become data centers on wheel. But it's not exactly data center because again, there are certain challenges that you don't find today at stationary data centers with respect to electrical magnetics interferences, challenges with respect to wire harnesses, all those issues that people don't really like to touch upon, but those are crucial. So the combination should be somehow be balanced, otherwise it won't work.
Thoughts, Ophir? I mean, especially thinking about smart cities and where we are right now.
Okay, so I agree that, for instance, Valens pioneered the data management challenge, but obviously you have three pillars. You have the sensors, you have the data, and then you need to process it in real time. So we were focused in the last years for really delivering a level 3, level 4, and even level 5 supercomputer that you will deploy in a car. And I can tell you that NVIDIA for many years has been developing cutting edge laptops, desktops, servers, but definitely self-driving car computer is the most challenging one from performance perspective, power efficiency perspective, but even more safety. And we were focusing on, when we developed our Drive Xavier, our level 3, level 4 supercomputer, we were focused on the most strict regulations such as ASIL-D, and even for the software standard like ISO 2026. So you need to optimize and need to make sure that you are resilient and optimize top to bottom, from the software level into the systems, into the operating systems and the processors itself. Overall, all those advancements can generate new use cases such as robotaxis, and even if you think about, I would call it the Amazon effect. So probably 10 years ago, we went to the store and we were buying merchandise. Today, everyone is using our mobile phones, and the merchandise come to us. So think about trucks. It's a huge industry, $75 billion industry, and it will be more and more dominance in the next years. So think about self-driving trucks, allow drivers to rest, improve safety, and also make it more efficient from a mobility perspective. So overall, many advancements in technology that will generate new use cases in our lives.
Just to stay with you, from a safety perspective, do you feel confident where the industry is right now?
So again, when you develop a connected city or a self-driving cars, you need to start of thinking how to develop the algorithms, embracing artificial intelligence technologies, which are really mature in the last years. So that's the first point. Second point is really to to being able to run it in a safer mode on the edge at the device in the car. But I think that it's really difficult to anticipate all the corner cases, and for that, I expect that people will use more and more simulators. For instance, if you want to make a very safe AV, autonomous vehicle, you need to drive something like 10 billion kilometers. It will take you probably a few hundred years, and you need simulators in order to do it. So that's important part to have a complete view of safety.
Micha, your view on safety? I mean, I know you're focused on a lot of data around safety, but where are we right now? Give us the landscape.
So safety is definitely a big issue here, and especially with respect to cost. Because again, you can put in the car a lot of redundancy, but this will result in an extra cost to the level that no one will be able to afford that. So the trick with respect to safety is, first of all, to understand what is needed, and I think we know what is needed, but the big challenge from an architecture perspective, from solution perspective, is how to allow this level of safety without increasing the cost. And this is part of the architecture that Glen was also referring to. We need to be very creative. We call it smart architecture in the sense of, okay, there is a level of redundancy. You need to make sure that the car will meet with all the fail-safe and stuff like that. But the challenge is, again, how to do it very low cost. I can tell you that it reached a point that the connectivity itself that you're going to be provided is expected to help you to lower the cost. So instead of using 4 cables, because if one will break, you need a backup, the trick is to do it with fewer cables. The challenge is there a way to go from star topologies to ring topologies, for instance, where you know that if one piece of equipment breaks, you can still come up with a different route. Those are the challenges, and unless we'll fix it, they're not going to be AV on the roads. So that's crucial.
Did you want to add to that? Or?
Sure. I think what I would also say is safety has to be first and foremost in your mind at all times. If you think about automated driving today, it's really the vehicles on the road today are still engineering development vehicles. So they're not production vehicles. These are highly modified vehicles and that's why we have safety drivers in those vehicles. And so you have to be incredibly sensitive and mindful about your safety protocols and how you train those drivers and how you ensure that your cars that are out being tested are not putting anybody in the car or around that car at risk. And that's going to occur for the next few years as we continue through development. As Micha was saying, relative to safety, longer term as we think about it, the expectation is ADAS and level 3 and level 4 are going to be much safer systems than manually driven cars. But you also have to make sure that there is a clear understanding from the consumer of what the capability of the vehicle is, so that they're not overestimating what that car can do, and that they understand its role and its capabilities. And right now, we see a little bit of a mismatch. People think, when we say autopilot or we think something like, or highway pilot, they think, well, they don't have to be engaged. And the current state of the art is they do. And so that's going to be a really important part. And then the final aspect I would say is, and I think, Ophir, you made a really good point. We have to have really good simulation and modeling tools so that before we put cars on the road with these features, we're able to validate the technology, the algorithms, the artificial intelligence, the governing rules for the car, so that we understand how they're going to behave when they see these use cases. And so simulation and that virtual development is going to be incredibly important for us.
When you mentioned the consumer, you played right into my next question, which was the fact that there was a story out yesterday that consumer trust in self-driving cars, particularly in North America, has plummeted following some pretty high-profile roadway incidents. 3/4 of Americans now, and you're all obviously connected to the U.S., are afraid to ride in an autonomous vehicle, and it's not who you think. The group that's most afraid is not maybe who you think. It's millennials that are the most afraid. Those between 20 and 37, 64% of them said they were afraid, and previously most were accepting. So that goes to your point on what's the application, how's it being used now, and how do you overcome that psychological barrier, right?
I think there's a couple things. I mean, if you think about what's happening today, In the US alone, there's about 40,000 traffic fatalities a year, which is well over 100 a day. So we don't really talk about those. We talk about the occasional few that happen where there's an autopilot type of incident. But part of that is because of the focus and the hype around automated driving and these technologies. So there's a lot of focus on that. And when any issue happens, it really gets magnified. And then that influences public perception. It's our job as the technology developers to continue to educating, kind of move past the hype and get into the data and get into the facts and educate the consumer base and our legislators and regulators on how these systems actually work and what those benefits are. ADAS is saving lives. It's making a tremendous impact, in terms of its ability to prevent accidents. As you go to level 2, level 3, level 4, it'll have even greater impact. Those are all the right things to do, but we have to do it in a responsible manner that helps educate the public, protects them while we're developing. And to date, most of the focus has been on the tech and the kind of the shiny object as opposed to what we're doing from a safety standpoint. And so the dialogue needs to shift, I think it will actually, to more about how are we safely deploying the technologies.
Micha, you were nodding your head as Glen was going through that. Additional thoughts on that?
Yeah, I think there is a fine line between, pushing the concept. I think that's what most of the industry was doing till recently, because it was really important to put a lot of marketing effort into it so people will realize that the future is not too far away. And this was extremely important in order, and actually we see it here. See how many companies are involved in that, see how many investors are putting money into it, how many governments are involved in that. And that was basically thanks to the work that was done and some companies that basically came up with statements such as, we'll have our cars ready in 2021 and 2022. And at a certain point, it did a great job. I think now we need to slow down a little bit, making sure that we don't oversell that. Because, as I said, every time that there is an attempt to show that we are almost there, it comes back as a backfire. So it's really a fine line that somehow the industry will need to deal with.
So you mentioned timing, so I'll just stay with you on this question. What are realistic development times then for level 4 or level 5?
Yeah, so going back to what Glen just said, I think you need to divide between commercial vehicles to passenger vehicles. Commercial vehicles, we believe it will be around already in 2023, 2024. That's more or less. Passenger vehicles, that's a different topic. So some companies will try to do it already in 2024, 2025. But there is a big if. And again, it's safety, but at least from my perspective, I think the most important one is cost. How many people will be willing to afford or will be willing to consider paying extra, as Amnon Shashua said, 12 grand for a level 4 car? That's a big question.
Ophir, thoughts on timelines?
So timelines really has a few parts. I think one of the important steps are the maturity of the technology. And from NVIDIA perspective, we deliver this year two major building blocks. One is level 3, level 4 processors with a full stack of software and algorithms. We know that the car will generate probably 2 petabytes of data every year and will need at least 25 deep neural networks in order to provide localization, perception, and other capabilities that you need. So we are providing the tools, and level 5 is coming later this year for robotaxi. So I believe that again, technology maturity is really evolving very fast, and we might see results earlier than what we imagine.
And some of the results that you believe will come the fastest, what's the biggest breakthrough that you see that maybe we're not even talking about yet?
So I believe that that we might see solutions coming earlier, such as robotaxi in more planned environments that can, solve the last mile issue. So think about people that want to come to work and they take train, and the last mile is always challenging, from home to the train and from the train to the work. So I believe that we will see specialized AV solutions to solve that problem. And in parallel, we'll see level 3, level 4 solution coming in the next 2 to 3 years.
Are you working with any communities or infrastructure groups to make some of that happen?
So basically, we do a few things. One of it, we sign agreements with leading companies such as Uber for developing level 5 mobility as a service. So that's one point. We do the same in China with Baidu and ZF for developing, again, mobility as a service in that region, huge region. And we are also developing in-house a full AV stack, not only the processors, the systems, but the full stacks and algorithms. Basically, car manufacturers can decide if they want to use our algorithms, our applications, or they want to develop their own. So I believe at the end there will be a mix. They will use some of our algorithms, they will develop some algorithms, and all of those activities will eventually accelerate the release of those solutions and the adoption in the cities.
So closing gaps oftentimes means developing learning in certain regions. Which regions, just asking the three of you, which regions or areas geographically are accelerating faster than others?
We are in Israel. I believe that from technology perspective, we are really leading, in many areas regarding to connected cars. I like the statement that the previous century was Detroit, and I hope that Tel Aviv can be the 21st innovation.
I think you have some support for that.
Yeah. But again, Israel is a small market, so I believe that innovation will come from Israel, but places like America, North America, and also China might adopt sooner those solutions in production.
Thoughts on geography, Micha?
Yeah, the easiest way that really will allow us to introduce cars faster is, if at a certain point you can press a button and automatically all the cars will be AV, okay? And I think that's our dream, huh? This will not happen in Tel Aviv. I don't think this will happen in North America. I would guess it's China. And this will simplify the solution, because unfortunately the biggest problem is that still are human drivers. If you eliminate the issue, everything becomes much easier from technology perspective.
Especially if the government tells you so.
Especially if the government tells you so.
Yeah, there's a couple of different dimensions to adoption. The first is, do you have the technology resident in the market? So if you think about in that regard, really the US is still really leading automated driving, and that goes back to the DARPA challenge roots, which was the origin really of the whole automated driving trends and those technologies. And so that install base really pushed Waymo, it pushed a number of companies, Autonomy, Automatica, the companies that we've acquired, ahead of the rest of the world relative to automated driving. And a lot of credit goes to Google and Waymo for really being out there in front. The other dimension, though, is the market and relative to the market. And is the market willing and able to receive that? And if you think about that, parts of the US are certainly there. Cities like Singapore, Dubai, Shanghai, other cities that have a very long-term view of their infrastructure and urban planning are being very aggressive about preparing for automated driving because they see it as an essential solution to their issues. So that's going to be another dimension to that. And then finally does the market have the right basically composition to support automated driving services, whether it's a first mile, last mile, or it's a mobility on demand point-to-point service. And again, that tends to be urban markets that have the density required, like a New York, like a San Francisco, LA, Shanghai, Dubai, those same areas. So as we look at deployment, we look at it along those three dimensions, and you're starting to see real acceleration there. So we operate in Singapore today, we operate in Vegas, Boston, Pittsburgh, and Mountain View, and what we see is those are all markets that are reaching quickly for it. Europe, I think, will come along, but it's cities like Amsterdam, London, and others are being a little bit more thoughtful about how they're approaching it.
Questions from the audience in the final 5 minutes here before I offer up my final questions. Yes, sir, in front.
Yeah. Do you see a big difference between direct tech coming from Europe versus the US?
From the
Authorities.
So in terms of regulations, the regulatory environment in the US and Europe, yeah, there is a difference there, and that's historically always been the case. When you think about the EU, on the one hand, you have a more unified body there looking across those, but generally speaking, there's more regulations around privacy concerns. There's more it's a little bit cleaner from a liability standpoint. They typically put that onto the operator of the vehicle. And it evolves differently than regulations do in the US or in North America. In North America, you have strong municipality capability. So if you're operating within a municipality, they have a lot of control over what can be done there. At the federal level, that's a different animal altogether, as it tends to move a little bit more slowly. But in general, whether it's I would say for North America or the US, we're not seeing the regulatory environment impede development at this point in time. They're still really assisting and trying to push it forward.
Would you expect the GDPR to be very stiff on this matter?
So you're talking about in Germany and in Europe? Yeah, generally speaking, they're going to be very, I would say, thoughtful and cautious about how they would roll this out. But having said that, with the strong consumer pull for ADAS and with the safety benefits and the societal benefits around deployment of mobility on demand in cities, they recognize there's a strong pull for it as well. So they recognize they don't want to be marginalized by seeing North America and Asia moving quickly and leaving Europe behind, because the German OEMs, they do their development primarily in Europe. They need to be competitive. So there is a lot of pressure as well to keep pace with the rest of the world.
Additional question from the audience. So I have a final question for the three of you. There are a number of startups in the audience, a number of startups here, who are offering their own solutions to close the gaps to autonomy. You can meet them in the hall next door. What is your advice to those folks who are trying to pitch you on those solutions? We'll start with Glen.
Sure. I think the one thing I would, really two points. One is make sure you have a clear understanding of what your technology, what problems it really solves at the OEM level. Because if you're trying to sell your technology ultimately through a vehicle manufacturer, you need to understand what problem am I solving? Can that be quantified? What's the value prop to the OEM? The second point I would make is that I would say spend time with those in the automotive value chain to understand how technology moves from a very nascent state to a fully deployed state. It can take a long time, and you have to be patient with that and understand how that process works so that your technology is finding its way into the end application.
Yeah, so we are on the startup side. So first of all, thanks for the advice. But I
didn't really consider you a startup anymore.
We're not a startup, yeah, but we're still pitching our technology and concept. And I fully agree with Glen. And we are out there for several years. I think what is really important is to understand that automotive is a different industry. It's a different creature, not necessarily one that startups normally will have in mind, given the fact that it takes time. You need a lot of time. First of all, you need to develop something, then you need to convince people, then you need to get into POCs, like the previous panel was discussing, and then you do another POC, and then you start running over money. And then finally you get a sign of life, But then you understand that even if you are successful, there is a design win. It will take 6, 7 years, at the best case, to see some revenues. This is really tough for startups. I think it's also quite a big question with the way that investors and the VC communities are dealing with that. But I think that the promise is so big, and that's the reason why you see so many companies. So you need a lot of patience and make sure that you do something that the industry will appreciate and need.
All right, you're definitely not a startup.
So we like to treat ourselves as a big startup with 12,000 employees. But really, I think it's important, you know, as a startup to develop your own solution, your own breaking through solution to solve something that's important for the AV market. We build an ecosystem partner platform called Inception. And I believe that it's important for us as a community to see how we can support each other. So we invite you to join our Drive ecosystem. We have 370 partners, startups, OEM, tier ones. So definitely, if you have a breaking through technology, we will be happy to partner and see how we can help each other.
All right, we can't leave this panel without talking about your T-shirt, so you might as well show it.
Yeah, okay, good.
Let's talk about the
elephant
in the car.
Yeah. Okay, I need to turn around.
Turn around.
Okay, that's a better part of me. Yeah. And by the way, this is with respect to connectivity again. As I said, we did the T-shirt because most of the companies in the ecosystem still don't necessarily understand the challenges that they will be facing with respect to connectivity. And it's about time that people realize that there is an elephant, a big one, in a very small car that somehow you need to treat well.
Right.
That's my job. I'm not the elephant, by the way.
All right, round of applause for our panelists. Thank you very much.